according to NEC 210.12. C. Arc fault circuit interrupter, or AFCI, protection is required for all 15 amp and 20 amp branch circuits that supply lighting outlets in dwelling units. It's crucial to understand the definition of an outlet according to NEC Article 100, which defines an outlet as a point in the wiring system at which current is taken to supply utilization equipment. The situation in question involves lighting fixtures in a master bathroom controlled by a single-pole toggle switch located in the adjacent master bedroom. The question is whether the NEC requires AFCI protection for the 15 amp, 120 volt branch circuit that serves those bathroom light fixtures and lights in other areas, but has no outlets in the bedroom, even though the switch is located in the bedroom. The key is to determine whether the switch itself qualifies as an outlet. In this case, the lighting fixtures in the master bathroom are indeed considered utilization equipment. The toggle switch in the master bedroom is used to control the flow of current to these fixtures. However, and this is important, the switch itself does not take current. It simply completes or interrupts an electrical circuit that supplies current to the fixtures. Therefore, the toggle switch does not meet the NEC definition of an outlet. Consequently, based on the NEC definition of an outlet, the branch circuit serving the bathroom light fixtures and lights in other areas does not require AFCI protection, even though the switch is located in a bedroom. While a local inspector might have a different interpretation, the NEC language is quite clear on this matter. The definition of outlet excludes switches, and therefore AFCI protection is not required for this specific circuit configuration. It's important to note that this interpretation hinges on the precise definition of an outlet as a point where current is taken to supply utilization equipment. Since the switch only controls the flow of current without itself consuming it, it doesn't fall under this definition. Let's delve deeper into the specifics of AFCI protection and its intended purpose. AFCI devices are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. These arc faults can occur due to damaged wiring, loose connections, or other insulation breakdown. The AFCI device monitors the electrical current flowing through the circuit and looks for characteristic patterns that indicate an arc fault. When an arc fault is detected, the AFCI device quickly trips the circuit, interrupting the flow of electricity and preventing a potential fire. The NEC requires AFCI protection in various locations throughout a dwelling unit, including bedrooms, living rooms, dining rooms, and other areas where arc faults are more likely to occur. However, the NEC also recognizes that certain types of circuits and equipment are less susceptible to arc faults and therefore do not require AFCI protection. This is where the distinction between outlets and switches becomes crucial. Outlets, by their very nature, are points where electrical devices are plugged in and used. This creates a higher risk of arc faults due to the potential for damaged cords, loose connections, or faulty equipment. Switches, on the other hand, are simply used to control the flow of electricity to a circuit. They do not typically involve the plugging in or unplugging of electrical devices, and therefore are considered to be less susceptible to arc faults. It's also important to consider the specific type of lighting fixtures that are being used in the bathroom. If the lighting fixtures are hardwired directly into the circuit without any plug-in connections, the risk of arc faults is further reduced. In this case, the absence of outlets in the bedroom, combined with the hardwired nature of the lighting fixtures, further supports the argument that AFCI protection is not required for this particular circuit. However, it's always best to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. They can assess the specific situation and provide guidance on the appropriate level of protection. It is important to remember that electrical codes and regulations are constantly evolving, and it is the responsibility of the electrician or contractor to stay up to date with the latest requirements. In addition to AFCI protection, there are other important safety measures that should be taken when installing electrical wiring in a bathroom. These include the use of ground fault circuit interrupter, or AFCI, protection for all outlets located within a certain distance of water sources, such as sinks, showers, and bathtubs. GFCI protection is designed to protect against electric shock by quickly interrupting the flow of electricity when a ground fault is detected. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCI devices are very sensitive and can detect even small ground faults that could be fatal. The NEC requires GFCI protection for all 15 amp and 20 amp 120 volt receptacles located in bathrooms, kitchens, and other areas where water is present. In addition to GFCI protection, it is also important to ensure that all electrical wiring is properly grounded. Grounding provides a safe path for electricity to flow in the event of a fault, preventing electric shock. The NEC requires that all electrical equipment be grounded to a common grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. It is important to ensure that all electrical connections are tight and secure. Loose connections can cause heat to build up, which can lead to fires. The NEC requires that all electrical connections be made with approved connectors and that they be properly tightened to the manufacturer's specifications. It is also important to protect electrical wiring from physical damage. Wiring should be run in conduit or other protective raceways to prevent it from being damaged by nails, screws, or other objects. The NEC specifies the types of raceways that are permitted for different applications. When working with electrical wiring, it is essential to follow all safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician. The information presented here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector before making any electrical installations or modifications. Firstly, always refer to the latest edition of the NEC for the most up-to-date requirement. Secondly, understand the definitions of key terms such as outlet and utilization equipment, as these definitions are crucial for interpreting the code correctly. Thirdly, consider the specific characteristics of the circuit and the equipment being used, such as whether the lighting fixtures are hardwired or plug-in. Fourthly, consult with a qualified electrical inspector or engineer if you have any doubts or questions about the code requirements. Fifthly, prioritize safety and always follow all applicable safety precautions when working with electrical wiring. Sixthly, ensure that all electrical work is performed by a qualified electrician or contractor. Seventhly, maintain accurate records of all electrical installations and modifications. Eighthly, stay informed about changes to the NEC and other electrical codes and regulations. Ninthly, participate in continuing education courses to enhance your knowledge and skills in electrical work. And tenthly, always strive to provide safe and reliable electrical installations for your clients and customers. Remember that the goal of the NEC and other electrical codes is to protect people and property from electrical hazards. By following these codes and regulations, you can help to ensure the safety of yourself, your family, and your community. Consider the scope of NEC 210.12 regarding dwelling units. The NEC defines a dwelling unit as a single unit providing complete and independent living facilities for one or more persons, including permanent provisions for living, sleeping, cooking, and sanitation. This definition is important because it helps to determine which areas of a building are subject to the AFCI protection requirements. For example, a hotel room would not be considered a dwelling unit, while an apartment would be. Let's consider some additional scenarios to further illustrate the application of NEC 210.12. Suppose that the bathroom lighting fixtures are controlled by a dimmer switch located in the master bedroom. Does the dimmer switch meet the NEC definition of an outlet? The answer is still no. A dimmer switch, like a regular switch, only controls the flow of current without itself consuming it. Therefore, the branch circuit serving the bathroom lighting fixtures would still not require AFCI protection, even though it is controlled by a dimmer switch. Now, suppose that there is a receptacle located in the master bedroom that is part of the same branch circuit as the bathroom lighting fixtures. In this case, the entire branch circuit would require AFCI protection. This is because the receptacle is considered an outlet, and NEC 210.12 requires AFCI protection for all branch circuits that supply outlets in dwelling units. It's also important to note that the NEC may have different requirements for AFCI protection in other types of buildings, such as commercial buildings or industrial facilities. Always consult the specific requirements of the NEC for the type of building you are working on. There are a few exceptions to the AFCI protection requirements in NEC 210.12. For example, AFCI protection is not required for branch circuits that supply only fire alarm systems. This exception is intended to prevent false tripping of the AFCI device, which could disable the fire alarm system. Another exception is for branch circuits that supply only life safety equipment, such as emergency lighting. This exception is also intended to prevent false tripping of the AFCI device, which could compromise the operation of the life safety equipment. In these cases, other safety measures, such as regular inspections and testing, are used to ensure the reliability of the equipment. The NEC is a complex and constantly evolving document. It is essential for electricians and contractors to stay up to date with the latest requirements in order to ensure the safety of their work. One way to stay informed is to attend continuing education courses and seminars. These courses can provide valuable insights into the NEC and other electrical codes and regulations. Another way to stay informed is to subscribe to industry publications and online resources. These publications can provide updates on changes to the NEC and other important industry news. By staying informed and following all applicable codes and regulations, electricians and contractors can help to create safer electrical installations for everyone. In conclusion, understanding the nuances of the NEC, particularly the definition of an outlet and the requirements for AFCI protection, is crucial for ensuring electrical safety in dwelling units. While a switch controlling bathroom lighting from an adjacent bedroom does not typically necessitate AFCI protection, it's essential to consider the entire circuit and consult with qualified professionals to guarantee compliance and safety. Always prioritize safety and adhere to the latest codes and regulations to protect people and property from electrical hazards. This includes understanding the purpose of AFCI and GFCI protection, proper grounding techniques, and secure connections. Remember that electrical codes are in place to protect life and property and must be followed.